When the Sky Falls, Why Asteroids Still Matter, and the Truth About 2024 YR4. On a freezing morning in Siberia in 1908, the sky exploded. People hundreds of kilometers away heard a roar like artillery fire. Windows shattered. The ground shook. In the forest near the Tunguska River, more than 80 million trees were flattened like matchsticks. Witnesses later said it felt as if a second sun had appeared in the sky. And yet no bomb had been dropped. No volcano had erupted. The most likely culprit was something far older and more mysterious, an asteroid. More than a century later, humanity is still looking nervously toward the sky. In late 2024, astronomers discovered a new near-Earth asteroid called 2024 YR4. For a short time, scientists calculated that it had more than a 3% chance of striking Earth in 2032. The number may sound small, but in planetary defense, that was enough to trigger worldwide attention. Suddenly, headlines exploded across the internet. Could an asteroid hit Earth? Is this another Tunguska? For many people, it sounded like science fiction becoming real. But here is the good news. According to the latest observations, 2024 YR4 is no longer considered a threat to Earth. Additional tracking reduced the impact risk to nearly zero. Still, the fear surrounding YR4 revealed something important. Humanity is not as protected from space as we sometimes imagine. The ancient danger above our heads. Asteroids are rocky leftovers from the birth of the solar system about 4.6 billion years ago. Most drift safely in the asteroid belt between Mars and Jupiter, but some wander dangerously close to Earth. Scientists call these objects near-Earth objects, or NEOs. Most are harmless. Tiny ones burn up in the atmosphere every day like shooting stars. But larger asteroids can survive the fall, and when they do, the results can be catastrophic. The dinosaurs learned this lesson the hard way. About 66 million years ago, a giant asteroid roughly 10 kilometers wide slammed into Earth near modern-day Mexico. The impact triggered global fires, enormous tsunamis, and climate collapse. Around 75% of all species vanished. That single collision changed the history of life itself. Fortunately, extinction-level impacts are extremely rare, but smaller impacts happen much more often, and smaller does not mean safe. The day Siberia burned. The Tunguska explosion remains one of the clearest warnings humanity has ever received from space. On June 30, 1908, an object estimated to be around 50 to 60 meters wide entered Earth's atmosphere over Siberia and exploded before reaching the ground. The blast flattened more than 2,000 square kilometers of forest. Some estimates suggest the explosion was hundreds of times stronger than the Hiroshima atomic bomb. The terrifying part? It never even hit the Earth. At asteroid speeds, Earth's atmosphere stops behaving like empty air. An incoming asteroid can travel faster than 18 kilometers per second, over 40,000 miles per hour. At those speeds, the atmosphere becomes almost like a solid wall. As the rock tears through the sky, air pressure builds violently in front of it. Heat rises instantly. The asteroid compresses, fractures, and finally explodes in a massive mid-air detonation called an airburst. That is why Tunguska left no crater. The asteroid destroyed the forest from the sky itself. If the same explosion happened above a modern city, the devastation could be unimaginable. Witnesses described heat so intense it felt as if their clothes were burning. Others believed the world was ending. Even today, scientists continue studying Tunguska because it revealed a frightening truth. Earth does not need a giant planet killer to suffer disaster. A relatively small asteroid can still erase an entire city. In 2016, the United Nations officially recognized June 30th as Asteroid Day, commemorating the Tunguska explosion and promoting global awareness of asteroid threats. More than a century later, the shockwave from that mysterious Siberian blast still echoes through human memory, reminding us that Earth remains vulnerable to the universe above. Not all asteroids are equal. When people hear the word asteroid, they often imagine a dinosaur-killing apocalypse. But asteroid threats exist on a spectrum. A rock around 20 meters wide, like the Chelyabinsk meteor that exploded over Russia in 2013, can shatter windows across a city and injure thousands of people. A rock around 50 to 60 meters wide, roughly the size of Tunguska or 2024 YR4, is often called a city killer. It can flatten an entire metropolitan area. At around 140 meters, an asteroid becomes what astronomers call a potentially hazardous object, capable of devastating a region or a small country. And once an asteroid reaches 1 kilometer or larger, the danger becomes global. Dust and debris could block sunlight, damage agriculture, and disrupt Earth's climate for years. The universe does not separate danger into neat categories, but scientists must, because understanding size means understanding survival. Then came 2024 YR4. When astronomers first detected 2024 YR4 in December 2024, alarms quickly spread through the scientific community. The asteroid was estimated to be roughly 53 to 67 meters wide, surprisingly similar in size to the object believed to have caused the Tunguska event. That comparison alone was enough to make people uneasy. Even more concerning, YR4 briefly reached level 3 on the Torino scale, a system scientists use to measure asteroid danger. The Torino scale combines the probability of impact, the asteroid's size, and the amount of destruction it could cause. Most asteroids remain at level 0, meaning no danger. A level 3 object is different. It does not mean certain catastrophe, but it does mean astronomers must pay close attention. For weeks, observatories around the world turned their telescopes toward YR4. NASA, the European Space Agency, and major observatories gathered new data day and night. Then something fascinating appeared. YR4 was not a smooth rock at all. Scientists discovered it likely had a flattened, potato-like shape and spun incredibly fast, completing one full rotation in about 20 minutes. Researchers also observed something called the Yarkovsky effect. As sunlight heats one side of an asteroid, the surface later releases that heat back into space. That release creates a tiny push, almost like a microscopic rocket engine. Over decades or centuries, even this weak force can slowly change the orbit of smaller asteroids. While gravity does most of the heavy lifting, the Yarkovsky effect is the subtle nudge that scientists must calculate to be 100% sure of a miss. Eventually, better observation showed YR4 would safely miss Earth. For now, the sky's most dangerous blind spot. One of the most unsettling lessons from modern asteroid science is this: we are not watching the entire sky. On the morning of February 15, 2013, at approximately 9:20 a.m. local time, a small asteroid about 18 to 20 meters wide streaked toward Earth from the direction of the Sun. Hidden within the Sun's blinding glare, the object escaped detection by ground-based telescopes until it was far too late. Moments later, the asteroid exploded 23 kilometers, 14.5 miles, above the Russian city of Chelyabinsk in a violent airburst, releasing energy equivalent to roughly 300 to 500 kilotons of TNT, several dozen times more powerful than the Hiroshima bomb. The shockwave shattered windows across the city and injured more than 1,200 people, most of them struck by flying glass. Ground-based telescopes work best at night. They scan dark skies searching for faint moving points of light, but objects approaching from the Sun's direction are often hidden inside daylight itself. In a cruel cosmic irony, some asteroids may approach from the brightest part of the sky. Scientists call this one of planetary defense's greatest weaknesses. To solve the problem, NASA is developing a space telescope called NEO-Surveyor. Unlike ground telescopes, it will search for asteroids using infrared heat signatures rather than visible light. Positioned in space, it will look outward from near the Sun-Earth system and search for objects hidden by solar glare. In other words, humanity is finally trying to look into its blind spot. Can humanity stop an asteroid? For the first time in history, the answer may actually be yes. In 2022, NASA carried out the DART mission, the Double Asteroid Redirection Test. A spacecraft deliberately crashed into an asteroid called Dimorphos to test whether humans could alter an asteroid's orbit. It worked. The collision successfully changed the asteroid's motion, proving that planetary defense is no longer just science fiction. But surprisingly, the Hollywood solution, simply blowing up an asteroid, may actually be one of the worst ideas. Destroying an asteroid with a nuclear explosion could transform one large object into thousands of smaller, high-speed fragments. Instead of preventing disaster, humanity might create a deadly cloud of cosmic buckshot. That is why scientists prefer gentler solutions. One idea is the gravity tractor, a heavy spacecraft that flies beside an asteroid for years, using its tiny gravitational pull to slowly tug the asteroid onto a safer path. Another proposed method sounds almost absurdly simple: painting one side of an asteroid white. Why? because lighter colors reflect more sunlight, changing how the asteroid absorbs and releases heat. Could strengthen the Yarkovsky effect and slowly push the asteroid away from Earth over time. It is strange to imagine. Humanity may someday save itself, not with explosions, but with patience, gravity, and sunlight. The people watching the wall. Planetary defense is not only about rockets and billion-dollar space agencies. Every night, somewhere on Earth, astronomers sit beneath cold observatory domes, searching for tiny moving specks of light. Many are professionals. Others are dedicated amateurs, using homemade equipment and sleepless determination. Most of the objects they track will never threaten Earth. Some will disappear back into darkness forever. But together, these observers form humanity's early warning system. Organizations such as the Minor Planet Center collect observations from around the world, constantly updating asteroid trajectories and calculating future risks. Every new observation slightly sharpens humanity's understanding of the sky. It is quiet work, patient work, but it may be some of the most important work on Earth, because these people are, in a sense, watching the walls of our world, looking up at the sky differently. Most nights, the sky feels calm and eternal. The stars appear peaceful. Space seems impossibly distant from ordinary human life. But asteroids remind us that Earth is not isolated from the universe. We live on a moving planet traveling through a cosmic shooting gallery. The story of 2024 YR4 ultimately ended with relief, not disaster. Yet perhaps that is exactly why it mattered so much. It gave humanity a rare gift, a warning without a tragedy. It reminded us that science matters, observation matters, preparation matters. Because somewhere beyond Earth, countless rocks still circle the sun in silence, and one day another object will appear in our telescopes. When that day comes, humanity will need to be ready.
It's time to study new words in context. 1. Culprit. Definition: the person or thing that caused a problem or bad event. Example: scientists believe the asteroid was the culprit behind the huge explosion. 2. Asteroid. Definition: a large rock that moves through space around the sun. Example: the asteroid passed close to Earth but did not hit it. 3. Catastrophic. Definition: causing very great damage or disaster. Example: a large asteroid impact could have catastrophic results for Earth. 4. Apocalypse. Definition: a terrible event that destroys much of the world or human life. Example: some movies show an asteroid causing an apocalypse on Earth. 5. Nudge. Definition: a small push or gentle move. Example: sunlight can slowly nudge an asteroid into a different path. 6. Unsettling. Definition: making people feel nervous, worried, or uncomfortable. Example: the sudden explosion in the sky was very unsettling to the people below. 7. Streaked. Definition: moved very fast, leaving a line or mark of light behind. Example: the meteor streaked across the dark sky before exploding. 8. Infrared. Definition: a type of light that is invisible to human eyes, but can be felt or detected as heat. Example: scientists use infrared cameras to find hidden asteroids in space. 9. Buckshot. Definition: many small pieces that spread out in different directions after being fired or broken apart. Example: blowing up an asteroid could turn it into dangerous buckshot flying through space. 10. Tug. Definition: a strong pull. Example: the spacecraft used gravity to slowly tug the asteroid away from Earth.
Comprehension questions. 1. What happened in Siberia in 1908? Answer: a huge explosion happened over the Tunguska forest, probably caused by an asteroid exploding in the air. 2. Why was the Tunguska event so frightening? Answer: it flattened millions of trees and showed that even a small asteroid can cause massive destruction. 3. What is 2024 YR4? Answer: it is a near-Earth asteroid discovered in December 2024. 4. Why did scientists worry about 2024 YR4 at first? Answer: early calculations showed there was a small chance it could hit Earth in 2032. 5. What is the Torino scale used for? Answer: it is used to measure how dangerous an asteroid might be. 6. Why did the Chelyabinsk meteor surprise scientists? Answer: it came from the direction of the sun, so telescopes could not see it clearly. 7. What is an airburst? Answer: it is an explosion that happens in the sky when an asteroid breaks apart in Earth's atmosphere. 8. Why did the Tunguska asteroid not leave a crater? Answer: it exploded in the air before reaching the ground. 9. What kind of damage did the Chelyabinsk meteor cause? Answer: the shockwave shattered windows and injured more than 1,200 people. 10. What is the Yarkovsky effect? Answer: it is a tiny force caused by heat from sunlight that can slowly change an asteroid's path. 11. Why are some asteroids called city killers? Answer: because they are large enough to destroy an entire city if they hit Earth. 12. What is NASA's DART mission? Answer: it was a mission that tested whether humans could change an asteroid's orbit by crashing a spacecraft into it. 13. Why might blowing up an asteroid be dangerous? Answer: because it could create many smaller dangerous pieces flying through space. 14. What is Asteroid Day? Answer: it is an international day created to raise awareness about asteroid dangers and planetary defense. 15. Why do astronomers continue watching the sky every night? Answer: they search for dangerous asteroids early, so humanity can prepare and protect Earth.